In the event of an emergency, the primary responsibility for the safety of occupants lies with the building owner or manager, facility manager, and prime contractor. Building codes typically require that doors in electrical rooms swing outwards with panic hardware. This is to ensure that occupants can quickly and easily exit the room in an emergency, such as an electrical fire or explosion. Failing to comply with code requirements can have serious consequences, including injury or death to occupants, legal liability for the building owner, manager, or prime contractor, and fines or penalties from building code inspectors. In the situation described, the prime contractor is responsible for ensuring that the electrical room door complies with code requirements. They have the authority to make modifications to the door, such as installing panic hardware. To address this, firstly, communicate the concerns to the prime contractor in writing. Secondly, refer to the specific code requirements that apply to electrical room doors. Thirdly, explain the potential consequences of non-compliance. Fourthly, request a meeting to discuss the issue and find a solution. Fifthly, consider contacting the building code inspector or fire marshal to verify the code requirements and enforce compliance. Additional safety considerations include ensuring that the electrical room is well ventilated to prevent the accumulation of toxic fumes, providing adequate emergency lighting in case of power failure, and training occupants on emergency procedures and evacuation routes. Electrical safety is paramount in any facility, and adherence to established codes and regulations is critical to protect lives and property. Electrical rooms, in particular, require careful attention to safety measures due to the inherent risks associated with high-voltage equipment and potential electrical hazards. The installation and maintenance of electrical equipment must conform to the National Electrical Code, or NEC, and relevant local codes. These codes provide detailed guidelines on wiring methods, overcurrent protection, grounding, and equipment installation to minimize the risk of electrical shock, fire, and explosions. Overcurrent protection devices, such as circuit breakers and fuses, are essential for safeguarding electrical circuits and equipment from damage caused by excessive current flow. Circuit breakers are designed to automatically interrupt the flow of electricity when a fault or overload condition occurs, while fuses are sacrificial devices that melt and break the circuit under similar circumstances. The selection and installation of overcurrent protection devices must be carefully considered to ensure that they are appropriately sized for the circuit they are protecting and that they can effectively interrupt fault currents. Grounding is another critical aspect of electrical safety. A properly grounded electrical system provides a low impedance path for fault currents to flow back to the source, allowing overcurrent protection devices to quickly trip and energize the circuit. Grounding also helps to minimize the risk of electrical shock by providing a reference point for voltage potentials, reducing the voltage between conductive surfaces and ground. Regular inspections and testing of electrical equipment are necessary to identify potential hazards and ensure that the equipment is functioning properly. Inspections should be conducted by qualified electricians who are familiar with electrical codes and safety procedures. Testing should include visual inspections, insulation resistance testing, ground impedance testing, and functional testing of equipment. Any deficiencies or hazards identified during inspections or testing should be promptly corrected to prevent accidents and ensure the continued safe operation of the electrical system. Arc flash is a dangerous phenomenon that can occur when electrical equipment is energized, resulting in a sudden release of energy in the form of heat, light, and pressure. Arc flash events can cause severe burns, injuries, and even death. To mitigate the risk of arc flash, electrical workers must wear appropriate personal protective equipment, or PPE, such as flame-resistant clothing, safety glasses, and gloves. Arc flash studies should be conducted to determine the potential arc flash hazard levels at different locations within the electrical system, and warning labels should be placed on equipment to alert workers to the hazards. Lockout/tagout procedures are essential for preventing accidental energization of electrical equipment during maintenance or repair work. These procedures involve isolating the electrical circuit by disconnecting the power source and applying a lock and tag to the disconnect switch to prevent it from being accidentally turned on. Only authorized personnel who have been properly trained in lockout/tagout procedures should be allowed to perform maintenance or repair work on electrical equipment. Electrical safety training is crucial for all workers who may be exposed to electrical hazards. Training should cover topics such as electrical codes and standards, hazard recognition, safe work practices, and the proper use of personal protective equipment. Regular refresher training should be provided to ensure that workers remain knowledgeable and proficient in electrical safety procedures. In addition to the above measures, good housekeeping practices can also contribute to electrical safety. Keeping electrical rooms and equipment clean and free of debris can help to prevent fires and other hazards. Electrical panels should be properly labeled to identify the circuits they control, and access to electrical equipment should be kept clear to allow for safe operation and maintenance. The National Fire Protection Association, or NFPA, is a leading organization that develops and publishes codes and standards related to electrical safety. NFPA 70, the National Electrical Code, is the most widely adopted electrical code in the United States, and it provides comprehensive requirements for the safe installation and maintenance of electrical systems. NFPA 70E, Standard for Electrical Safety in the Workplace, provides guidance on protecting workers from electrical hazards in the workplace. Adherence to NFPA standards is essential for ensuring electrical safety and compliance with regulatory requirements. Local jurisdictions may also have their own electrical codes and regulations that must be followed. It is important to be familiar with the applicable codes and regulations in the area where electrical work is being performed. Building permits may be required for electrical installations, and inspections may be conducted by local building inspectors to ensure compliance with code requirements. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. By following established electrical codes and safety procedures, you can minimize the risk of accidents and ensure the safe operation of electrical systems. The information provided in this narration is intended for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician or electrical engineer for specific recommendations and guidance on electrical safety issues. Understanding the National Electrical Code, or NEC, is crucial for anyone involved in electrical work. The NEC is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It's updated every 3 years to reflect the latest advancements in technology and safety practices. Article 90 of the NEC outlines the purpose and scope of the code. It's essential to understand that the NEC is not a design manual, but rather a set of minimum requirements for safety. Chapter 1 of the NEC covers general requirements, including definitions, rules for electrical installations, and requirements for working spaces around electrical equipment. Article 110 is particularly important as it addresses the requirements for electrical installations, including examination, installation, and suitability of equipment. Chapter 2 of the NEC deals with wiring and protection. This chapter covers topics such as wiring methods, conductor sizing, overcurrent protection, and grounding. Article 210 addresses branch circuits, which are the circuits that supply power to outlets, lighting, and other electrical equipment. Article 215 covers feeders, which are the circuits that supply power from the service entrance to branch circuit panels. Article 220 provides rules for calculating branch circuit, feeder, and service loads. Chapter 3 of the NEC covers wiring methods and materials. This chapter specifies the types of wiring allowed for different applications, as well as the requirements for conduit, cable trays, and other wiring support systems. Article 300 covers general requirements for wiring methods, including protection against physical damage, corrosion, and other hazards. Article 310 deals with conductors for general wiring, including ampacity ratings and installation requirements. Chapter 4 of the NEC covers equipment for general use. This chapter includes requirements for switches, receptacles, lighting fixtures, appliances, and other electrical equipment. Article 400 Addresses flexible cords and cables, including their allowable uses and limitations. Article 430. Covers motors, motor circuits, and motor controllers. Chapter 5 of the NEC covers special occupancies. This chapter includes requirements for hazardous locations, healthcare facilities, and other special types of occupancies. Article 500. Addresses hazardous locations, which are areas where flammable gases, vapors, or dust may be present. Article 517. Covers healthcare facilities, including requirements for patient care areas and emergency power systems. Chapter 6 of the NEC covers special equipment. This chapter includes requirements for electrical signs, swimming pools, and other special types of equipment. Article 600. Addresses electric signs and outline lighting. Article 680. Covers swimming pools, fountains, and similar installations. Chapter 7 of the NEC covers special conditions. This chapter includes requirements for emergency systems, standby power systems, and other special conditions. Article 700. Addresses emergency systems, which are designed to provide power during a power outage. Article 701. Covers legally required standby systems, which are required by law to provide power to certain essential loads. Chapter 8 of the NEC covers communications systems. This chapter includes requirements for telephone, data, and cable television wiring. Article 800. Addresses communication circuits, including telephone and data wiring. Chapter 9 of the NEC contains tables and examples that are used to apply the NEC. These tables and examples provide guidance on conductor sizing, overcurrent protection, and other calculations. Table 310.15b16 is a commonly used table that provides ampacity ratings for conductors. Annex C provides examples of how to calculate branch circuit, feeder, and service loads. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing overcurrent protection devices to trip and de-energize the circuit. Bonding connects all metal parts of an electrical system together, creating a low impedance path for fault current. Article 250 of the NEC covers grounding and bonding requirements. It's essential to understand the difference between grounding and bonding and to follow the NEC requirements carefully to ensure electrical safety. Electrical calculations are an important part of electrical work. These calculations are used to determine conductor sizes, overcurrent protection device ratings, and other electrical parameters. Ohm's law is a fundamental principle of electrical calculations. Ohm's law states that voltage equals current times resistance, or E equals IXR. The power formula is another important electrical calculation. The power formula states that power equals voltage times current, or P equals EXI. Understanding these formulas and how to apply them is essential for performing accurate electrical calculations. Working with electricity can be dangerous, and it's important to follow safe work practices at all times. Always de-energize circuits before working on them. Use appropriate personal protective equipment, or PPE, such as gloves, safety glasses, and arc flash suits. Follow lockout/tagout procedures to prevent accidental energization of circuits. Be aware of the potential hazards of electricity and take steps to protect yourself and others from harm. Regular electrical inspections are essential for maintaining electrical safety. Inspections should be performed by qualified electricians who are familiar with the NEC and local electrical codes. Inspections can identify potential hazards, such as damaged wiring, overloaded circuits, and improper grounding. Any deficiencies identified during inspection should be corrected promptly to prevent accidents and ensure electrical safety. Electrical safety training is essential for all workers who may be exposed to electrical hazards. Training should cover topics such as electrical codes, safe work practices, and the proper use of personal protective equipment. Regular refresher training should be provided to ensure that workers stay up to date on electrical safety procedures.